In part 1 we noticed that hyperbolic functions are very similar to trigonometric functions. And here we continue and we find that there are even more and more similarity between the two kind of functions. We will start with hyperbolic Pythagorean identities. Cosine hyperbolic to the power of 2x minus sine hyperbolic to the power of 2x equals 1. And exactly as we did with the trigonometric functions, we can divide everything by cosine hyperbolic to the power of 2x, and we get the following identity. 1 minus tangent hyperbolic to the power of 2x equals secant hyperbolic to the power of 2x. Now again, we will do exactly as we did with the trigonometric function. We are going to divide everything by sine hyperbolic to the power of 2x. We are getting this identity, that the cotangent hyperbolic to the power of 2x minus 1 equals cosecant hyperbolic to the power of 2 of x. From the main Pythagorean identity of cosine hyperbolic to the power of 2x minus sine hyperbolic to the power of 2x equals 1, we are getting two very useful Pythagorean identities. The first one is 1 plus sine hyperbolic to the power of 2x equals cosine hyperbolic to the power of 2x. And we also get cosine hyperbolic to the power of 2x minus 1 equals sine hyperbolic to the power of 2x. Here are all the important hyperbolic Pythagorean identities. Here are more hyperbolic identities. Sine hyperbolic of x plus y equals sine hyperbolic x times cosine hyperbolic y plus cosine hyperbolic x times sine hyperbolic y. And cosine hyperbolic of x plus y is cosine hyperbolic x times cosine hyperbolic y plus sine hyperbolic x times sine hyperbolic y. We have also a specific case for which x equals y, and we get here that sine hyperbolic of 2x, which is also sine hyperbolic of x plus x, is this, but as you can see, the two parts are exactly the same, so we get 2 times sine hyperbolic x times cosine hyperbolic x. What about cosine hyperbolic 2x? We can write it as cosine hyperbolic of x plus x. And we get that, which is cosine hyperbolic to the power of 2x plus sine hyperbolic to the power of 2x. Please pay attention, this is not 1. There is a slight differences between the trigonometric Pythagorean identity and the hyperbolic Pythagorean identity. Now I can write it in other ways using this. So as you can see, in hyperbolic functions, we have cosine hyperbolic to the power of 2 minus sine hyperbolic to the power of 2 equals 1. So there's no plus, there's minus, which means also that you cannot commute that, but it has to be in this order. So if I'm using this, then I will replace this by 1 plus sine hyperbolic to the power of 2 of x, and I get this. But also, I can substitute for the sine hyperbolic to the power of 2x, which is this. So here I'm substituting for that, and I get this. So here is a summary for that. Cosine hyperbolic 2x can be written also as this one, and also as this one. This is very useful, because now I would like to get a reduction formula exactly as I did with trigonometric functions. If you observe what I have here, I have sine hyperbolic to the power of 2x, so I would like to figure out what is sine hyperbolic to the power of 2 of x, and by solving that, I get that this is cosine hyperbolic of 2x minus 1 over 2. This is a reduction formula to reduce the exponent in the sine hyperbolic x from 2 to a linear expression of the cosine hyperbolic. And from here, I'm going to get an identity that will be a reduction formula for the cosine hyperbolic to the power of 2x. And I get that. I would like just now to give a small summary when I'm comparing hyperbolic functions to trigonometric functions. You have to remember that here we have cosine hyperbolic to the power of 2x minus sine hyperbolic to the power of 2x equals 1. Compared to this, then we have this one. Now it is exactly the same. And here we have this and this and this for the cosine hyperbolic of 2x. And here, for cosine 2 theta, we have this, and this, and this. The cosine hyperbolic function is even, exactly as the trigonometric cosine function. And the hyperbolic sign is odd. And also, the sine function is odd.